In this video tutorial, we will be taking some questions on SARIMA models. So we'll be taking some questions. First on our list is question 1. So you can say compute SARIMA. You can say compute SARIMA, 0, 1, 0 and 1, 0, 0 with seasonality of 4. So we can be asked to compute that. Well, it's quite easy to say solution. For more on this topic, you need to subscribe to this channel. Now, we'll take from the simpler part to the more complex one. We recall that our simpler model can be written as phi p d p phi p s d ps. We have our differential part, do the seasonal part. We have the non-seasonal part. We have xt to be equal to our moving average part. Then ET. This is the model. Now, our autoregressive, of course, this is P, this is PDQ, and the seasonal part PDQ. Now, for the autoregressive part, the non-seasonal part, we have 0, which is nothing. For the differential, our differential, we have phi b to be equal to 1 minus b raised to the power of b, which is equal to 1 minus b. We have b to be 1. Also, for the seasonal part, we have this. For the seasonal part, that means phi p then s b p. This s is 4, while our p is 1. P s to be equal to 1 minus phi. This is ps. Our p is 1, comma s is 4. Then b, we have ps here. Our p is 1 multiplied by 4. That is all we get. So we can write it as 1 minus pi 1 comma 4. Then b 1 multiplied by 4 is 4. Of course, the differential part is 0, and the moving average part for our seasonality is also 0. So we don't have anything here. So it will now be remaining our ET. So we can write this out from the model. From the model, we can write our SARIMA model to be. We can write our SARIMA model to be 1 minus pi 1 4 b 4 for this part. Now, see, this part is 0, this part is nothing, this is 0 too. Now we have this part, which is this, which is equal to 1 minus b. Then we'll write out our xt equal to, of course, our moving average, we don't have anything for it. Our moving average part, which is this, is 0. That means the non-seasonality, the one with the non-seasonality, the one with seasonality is also 0. So we have What is remaining is ET. So this becomes our model for the given question. This becomes our model for the given question. For more on this topic, you need to subscribe to this channel. We'll also take another question so that we better understand how to compute the SARIMA model. Now, the next on our list will be question 2. Compute SARIMA P 2 P 1 1 1 with seasonality 3. With seasonality 3. So, like we have said, solution. For more on this topic, you need to subscribe to this channel. The first thing to write out will be to write out the model. So we can write our model to be file 2 BP for the non-seasonal part, then file P S B P multiplied by S. Then we have the seasonal part. We also have the non-seasonal part. We have XP to be equal to theta non-seasonal part B and theta seasonal part D takes over of Q multiplied by S, then ET. So this is our model, the SARIMA model. The first thing to do is to compute the autoregressive part. So we compute this part first. And here, of course, we know that this is our P, this is our D, and this is our Q. This is our P for the seasonal part, this is our D, and this is our Q. This is the seasonality, which is 3. Now, we write this part out. This part, file P, B, P, will be equal to 1. We have it as 2. We have it as 2. It will be 1 minus pi 1 B1 minus pi 2 B2. So that is all we have. Now, we also write our differencing part. Our differencing part will now be, okay, the next on our list is the seasonal part. The seasonal part of our autoregressive is 1. We have P to be 1, the seasonality part. So our seasonality part will be pi P, comma S, then B, P, S to be equal to 1 minus pi 1, comma S is 3, B, S, S is 3, minus, okay. So this is 1 minus pi 1, which is P, 3. 3 is the seasonality. P, comma S, 1, comma 3. Then B raised to the power of the first one will not be PS. So the first one we have here to be just 3. To be 3 multiplied by 1. That means 1 multiplied by 3. So we have this. The next on our list is the seasonal part, the differencing part, the seasonal part. We have it as 1. So the D here is 1, the S here is 3. How do we compute this? We'll move over to this side of the board to do that. For more on this topic, you need to subscribe to this channel. So I'll be deleting this part of the board so we continue from where we start there. Now, we have our seasonal part to be our differential part ds, which is 1 minus b, to give us our b here is 1. The b here is 1. Also, our s here is 3. So it is written as 1 minus b multiplied by s, which is 1 minus b 1 multiplied by 3, which is 1 minus b raised to the power of 3. Now, we have our non-seasonal part. The non-seasonal part is to give us the non-seasonal part is 2. So this is the same thing as 1 minus b raised to the power of b, which is 1 minus b raised to the power of 2. So this is what we have. Now, we also have our xt. We also have that of the moving average. The moving average is 2. The moving average is 2, so we have theta q then b raised to the power of q is equal to 1 plus theta 1 b plus b1 theta 2 b2. That's for that. Also, we have the moving average, the seasonal part. The moving average, the seasonal part, we have it to be theta q comma s b q s multiplied by s to be equal to 1 plus theta 1 s is 3, 1 comma 3 b 1 multiplied by 3 plus we have it to be we have the moving average part, the seasonal moving average part, which is this, just 1. So we have it to be 1 plus theta 1 comma 3 b raised to the power of 3. So we have finished computing what we have here, SARIMA 222111. This is it. All we need to do is to now put it in this form. We now put it in this form. Once we put it in that form, we have succeeded in writing our SARIMA model. And for you to do that, we do it on top. So we put it in the form here. We write it as for more on this topic, you need to subscribe to this channel. Now, we have this part, we have this part. So we write 1 phi 1b minus phi q b squared 1 minus phi 1 3 b raised to the power 3. We have our differential part, this is now to be 1 minus b raised to the power of 3 to be equal to, now, okay, we still have this, the seasonal part. The non-seasonal part is 1 minus b squared to be equal to This the moving average part. Now we are writing the moving average part is this and this. The moving average part will now be the first moving average part is 2, and the second moving average part, the seasonal part, is just 1. It's 1. So we have it to be 1 plus theta b plus theta 2 b squared and 1 plus theta 1 3 b 3 then e2. So this becomes our model. This becomes our model. This becomes our model for SARIMA 222111. So this is simply how to compute the SARIMA model. In case you are asked to compute the SARIMA model, given any question or any parameter, you'll be able to compute that. For more on this topic, you need to subscribe to this channel.